uh, 10 steps of data science. So this is the framework we have developed. And whenever we talk to customers who are embarking on their data science journey, we typically walk them through the 10 steps of data science, as we call, to make sure that they kind of go from inception to deployment, understanding all the key phases which are going to be used in the context of data science. Before we start the webinar, a couple of key logistics items and introductions. My company is called QuantUniversity, and we are an analytics advisory based out of Boston. We've been working with various financial services and energy clients since 2013. And we also run a couple of educational workshops. One is called as the Analytic Certificate program, primarily geared towards enthusiasts in analytics and data science who are interested in kind of either changing careers or getting a full deep dive of a 16-week program in analytics. We also have a fintech certification program for people who are interested in the various facets of fintech. And we also do 1 to 2 day workshops on various themes. And what you're going to be hearing for the next 20 to 25 minutes or so is a preview of an upcoming workshop which is happening in Boston. And my name is Krishnamurthy, and I'm the founder of QuantUniversity. I've been working in the area of analytics and data science for the past 15 to 18 years. I used to work at Citigroup and also worked at a company called MathWorks, which makes MATLAB. And I've consulted with more than 25 companies on various areas. My interest in data science goes back to my grad school days when we were doing a lot of statistical modeling, but we had challenges with respect to getting data, the right kinds of data, to build the real models which could be used in production. And fortunately, the last decade or so, we have been seeing a lot of enhancements in the context of both hardware and software tools. And we have an abundance of data available, which has made sure that the field of data science is flourishing. So in that context, we are putting together a masterclass on data science, forecasting, optimization, and AI. And the reason why we thought this workshop would be something which is timely is because it's not only about data. There are various aspects of forecasting, optimization, and artificial intelligence, which is kind of having a confluence effect in the field of data science. And we want to kind of get a perspective of how these areas are going to be affecting the way we build models in data science and machine learning. So this workshop is happening on Wednesday, and I would like to acknowledge the support of Babson College for hosting this workshop. And please, if you're not registered yet, go to qmasterclass.slashthat.com for registration. And at the end of this webinar, we're going to offer a coupon code for people who are interested to join this workshop at a discount. The workshop will have 4 components, and what you're going to be seeing in this webinar is going to be a preview of what we're going to be discussing in the data science in 10 steps part, which I'm going to be speaking about. And then Gustavo Vicentini, who's a professor at Northeastern University and who's also leading some of our efforts in the context of econometrics. So he's going to be looking at time series analysis and talking about how you have to model time series problems, especially in the context of forecasting. As you can imagine, financial data has a lot of time series related data sets, and it becomes challenging to think about models not only in the context of traditional financial econometrics, but also leveraging some of the newer technologies like neural networks and LSTMs and things like that. So Gustavo is going to do a masterclass giving you a highlight on the key advances in econometrics and forecasting. And then Anish, Shah, who's been working on optimization for a really long time, so he's going to be talking about frontier topics in optimization. So there's a lot of confluence between traditional optimization and machine learning. So he's going to bring both of them together and talk about some of the problems which are in the space and how the various tools which are available nowadays could be utilized for building optimization solutions. And then I'm going to connect the dots on some of the applications and frontier areas in AI and machine learning And we will also illustrate some case studies on building various kinds of models leveraging data science and machine learning techniques. So without further ado, I would kind of want to talk about the key aspects which you need to consider in the context of data science. Now, these 10 steps which I'm talking about, I would like to keep it really high level for the purpose of this webinar. And for a deep dive, I would invite you to come down to our masterclass. But these are the 10 steps I typically walk my students through when we teach a class in the context of data science. I've been teaching data science at Northeastern University for the past 5 years. And graduate students who are interested in building data science solutions typically come with the perspective that, we're going to be building machine learning models and we're going to be deploying it and we'll forget it. The data is going to be coming in and the models are going to keep auto-tuning themselves and we'll just move on to the next problem. It's not that easy. You have to kind of think about data science problems holistically. And these 10 steps is going to give you the perspective of all the key aspects you need to think about when you're building data science solution. So let me start out with these 10 steps. The first step is, even before you think about designing the data science solution, you have to articulate what your business problem is. Is it that you are trying to improve sales? Is it you are trying to improve the matching between what you are trying to do in terms of recommendations, in terms of understanding what you have seen in terms of data collected in the past? Are you looking for newer opportunities wherein you could get better value? Is it going to increase your productivity? Is it going to decrease your cost? All those are business-specific problems. And even before you start talking about data, you have to first articulate about what we are trying to achieve with a particular data science solution. The second question comes with, when you're talking about data science, if you do not have the data, unfortunately, you won't be able to do much. So the data-related questions, things you need to answer are things like, what data do we need? Where do we get the data if we do not have data? And even if you have the data, is it the right kind of data for the problem you have at hand? Many times, people think that we have a lot of data just because you've been storing data in various contexts. Just because you have some data doesn't mean that you can build out a data science solution. And also, you need to understand that many times you have to think about data as something which has to be engineered throughout the whole process, and you need to keep on collecting newer data sets. You have to figure out how do you store it, who's going to process it, all those aspects. So you need to have a data strategy, and that kind of leads to the third point, which is, what is your data acquisition and data preparation strategy? Are you going to be going to a vendor to source your data? Are you going to be scraping the data on your own? How do you actually get this data? Do you subscribe to the various data sets, or do you figure out do you already have this data set? And how will you access it? Is that something which you're going to be hosting through data lakes or other solutions internally, or will you have to download it from an external source? And once you get this data, what amount of pre-processing needs to be done? And also, the notion of data governance is becoming more and more important in the context of data science. And so you need to start thinking about, how do you govern the whole data science process? How do you version all your data sets? And in case you want to repeat some of the data experiments you've been doing, how do you go about leveraging those data sets which you have used in the past to make to adjustments and replicate those data sets? So the perspective I would like you to have is, even before you build out your first model, if you haven't answered these questions in an enterprise setting, it becomes extremely challenging for you to basically deploy or make these solutions viable within the enterprise. Many a times when you look at simpler solutions online, or you're trying to take a training course and they give you a data set, maybe downloaded from Kaggle or any other cleaned up data source, you kind of miss out a whole picture on the thought process which needs to be involved before you actually get to the modeling piece. People love the modeling piece. But unfortunately, 80 to 90% of the time in an enterprise is spent in cleansing and getting the data right before you could actually go and figure out like what nuggets of information you can get from these data sets. So that's the perspective I'd like you to have in the first three steps. So going beyond, the fourth step is actually very key. And I'm not going to talk a lot about it in this segment, but if you have the data set which you're going to be using to build out your solution, you need to be able to understand and explore and understand what you have, and you need to get the data in the right formats. And that goes through a lot of trial and error and also experimentation. You need to be able to figure out, whether certain data sets are actually usable. If there's a lot of missing data in your data sets, then you may have to do a lot of cleansing or remove some of the data sets. Then you may also have to think about, can you even infer relationships in the various variables you're considering when you're trying to model a data science problem. Many times, this phase, is missed out, and a lot of people directly go into the modeling piece, and then they think that, well, the models don't perform well. But it's just that you do not know what kind of data you have in the first place before you have actually gone and built out these models. So exploring and evaluating your data is key before you can even get to the modeling part. And then I take my students through a thought exercise, which is to build out a goal for what kind of an application are you trying to build. Is it a summarization problem? Are you understand from the data you're being collecting? Are you on a fact-finding machine? You're trying to figure out what happened in the past and how you can change your processes or keep doing what you've been doing in the past because what you have been doing has gone well. So it could be a fact-finding machine, kind of goes into the attribution mode. You're attributing results to things which you had seen in the past, and then trying to understand or uncover those relationships. And then also trying to understand the various relationships amongst various variables. So that could be in the context of a lot of graphs and charts, trying to figure out if there are any kinds of relationships between various variables. And lastly comes prediction. A lot of people put a heavy emphasis on forecasting and prediction, but prediction is just one of the many problems you could build in the context of data science. And if you're trying to predict, you have to have a very clear goal, because prediction basically means that you are learning from data, and you have either the right labels or the right metrics which you can use for learning and training your model. And then you have to think about testing whether you can actually leverage your models to do some forecasts and with a certain degree of confidence predict whether those forecasts are going to turn out right or not. The sixth piece I would like to talk about is very key, but I would like to emphasize that many a times people jump into algorithms and methodologies just because they think that that's the right approach. I typically advocate people to shortlist the various technologies or methodologies or algorithms, and it has to go through a brainstorming process. You do not want to choose any specific methodologies and tie down to particular methodologies and figure out, well, the methodology failed, meaning my data science problem is worthless. You should not come with that approach. You have to think about, well, what are the potential techniques we can use for a particular problem? And then comes the most important part. Every organization is different. Every organization has specific business constraints, technology constraints, expertise constraints. So you have to assess, where you can go with the data and the business problem and the goals you have in mind. And this becomes key because in case you are working on a very critical data set and you cannot send anything outside to a cloud, to a public cloud, forget about using some of the cloud services. You have to think about building something on-prem. And then comes the question, is it even worth building out an entire solution if you are not being able to articulate the value of that particular solution? So you need to build in that expertise on how do you kind of build out these solutions and what's the cost value proposition when you build out these solutions. And then comes the big question on whether you're going to be hiring all these resources to build out these solutions. Do you buy an existing solution which provides 80% of the capabilities you're looking for, or you're just going to access some solution which is out there on the cloud to build out your problem set? So the combination of 6 and 7 will kind of give you the path you would go about to leverage your various tools and methodologies to build out data science solutions. The 8th aspect is key in terms of establishing how are you going to make sure that the models and the methodologies you're actually building is going to work for the business problem you had at hand. Certain questions you may have to think about is, is this process repeatable or replicable? Is that something which I can continue working on and repeat in a production mode? And then how do you even evaluate whether the solution actually works? What performance metrics are we going to be using? And then how do you evaluate and validate your various models, especially when you're working in a financial setting and you have fiduciary responsibility to make sure that the models actually work? How do you evaluate the performance and validate those models? And then lastly, it's not all about technology and data and building cool models. It's asking the big question, is it really providing the business value we anticipate from this kind of an investment? Many times, you may think that just because you've invested a lot of time and effort in building out these solutions, it should give out, really usable results, and also it's going to generate a lot of value. But unless you are completely clear that this solution is going to generate value for what you are trying to do, it may just be an investment on a lot of resources without having a clear perspective of what value it's going to generate. So that's kind of key in making sure that you have a good set of criteria before you can even jump into deploying these solutions. Now comes the fun piece. Now you have defined the problem. You have looked at all the data sets you can potentially use. You have sourced the data. You've experimented with it. You've explored it. You've built out your models. You've tried various combinations of various models. Now, how do you choose which model you're going to be deploying once you have proven that this model actually has values? There is this notion of tuning algorithms, because many a times, most of these problems are search problems. You're trying to search for the best combination of assets, or the best combination of parameters you could potentially use for your solution. But you also have to understand that your solution may not be the best solution. So how do you go about tuning your algorithms and choosing the right kinds of algorithms? So here it gets a little technical, but you have to understand that there are a lot of scientific techniques which could potentially be used. Things like hyperparameter tuning. These are the parameters you as a modeler would be using for the models. For example, if I have a constraint that I have to run this algorithm, but the results need to be out in 1 hour, then I need to stop the solution within an hour and make sure that I use the results, whatever best results I get within that 1 hour. But also aspects like bias variance trade-offs. And also sometimes the problem may not be balanced. For example, fraud detection problems or anomaly detection problems. 99% of the data may be of one class and 1% could be of a different class. If you just evenly balance out these classes when you're learning, most models and algorithms learn from the majority class because they're trying to generalize these solutions. So you'll have to do additional stuff if your goal is to detect anomalies or you're trying to build out outlier detection kinds of examples. And then many a times, you may have to use a combination of various techniques. It may not just be one technique. You could use an ensemble of various techniques. And that's where you may have to consider some of the ensemble methodologies, which leverage not only one, but multiple algorithms or even multiple iterations of the same algorithm. And then last but not the least, the industry is trying to figure out if this whole search problem where you're trying to figure out like which combination of parameters gives you the best result could be automated. There's a lot of emphasis on this newer methodology called as AutoML or automatic machine learning. And a lot of companies are trying to invest in figuring out ways in which you can structure the problem and you use computational power to scale problems and then give you a sorted list of best performing algorithms and you'll choose the best algorithm. So that's another thing you could potentially use for figuring out which iteration of the algorithm you're going to be deploying in production. And then the last aspect is, it's not just sufficient that you build out all the infrastructure and technology and have an algorithm. You need to figure out how do you get these insights to the key decision makers. So how does this process reach these decision makers? So you have to think about, well, where do we deploy this? Should we put it on the cloud? Should we deploy it on site? How frequently should the model and the data be updated? How do you govern this whole process? This is most companies, it's relatively new, and you may not be able to use traditional methodology. So how do you govern these processes? Who's going to be responsible for the entire process? And what roles responsibilities? And many of the key enterprise aspects, like speed, disaster block if something catastrophic happens, all those things need to be thought about when you're deploying these solutions. I wanted to end at 10, but then I thought about a bonus one, which most people do not really factor when they're building out data science solutions. And this is something which is becoming extremely important. And that's how do you monitor the efficacy of your solution? Because it's not just deploying and kind of sitting back and seeing the results automatically coming through it. You may have to think about the strategies for retuning your model, because there is going to be decay in the model. The model may not perform optimally after a certain time. So how do you think about retuning the model? Even to understand when to retune your models, how do you monitor and understand what actually needs to be monitored to figure out when the solution becomes useless or it's time for retuning? And then there are new data sets always coming in. How do you augment your processes and how do you augment your data sets to bring in newer factors or newer data points? And also the models are also enhancing. If you go to any of the machine learning conferences, every time you see newer innovations happening. So what's your process of incorporating newer innovations? And this becomes very interesting, especially in the context of this is a very change in a lot of academic and industry advancements. So those are the 10 plus one bonus step. If you are interested in learning more, please consider attending the QuantUniversity Masterclass, and that's happening on February the 6th at 8:30 in Boston. It's also going to be streamed online. So for tickets, you can go to qmasterclass.splashstack.com. And for participants of this webinar, if you use the code 50OFF, you're going to get 50% of all the tickets. So I hope to see many of you out there. And if there are any questions, I'll take them now.